Hi, everybody. This is Nalini Elkins with Industry Network Technology Council. I hope you can all hear me okay. We are recording this webinar, so if you have any problems or questions, then please let me know. And go ahead and send me a note in the chat window if you would. Let me know that you're hearing me okay. Okay, so I'm hearing that it's a bit muffled. Let me try something else. Okay, is this a little bit better? Maybe you can send me a note to let me know if this is better. Okay, great, perfect. Thank you so much. If you have problems along the way, please let me know. Okay, great. So let's go ahead and get started. So what we are doing, this is a multi-year project in collaboration with the India Internet Engineering Society. We are both nonprofits, the Industry Network Technology Council and IISOC. And what we want to do is help enterprises, organizations who have their own networks migrate to IPv6. And to that end, we are setting up these series of webinars, and we've had, I'll probably be doing this for 2 or 3 years already. So great. A tiny bit about me: I've been working in the industry for quite a bit of time, mostly in performance monitoring and network diagnostics for large networks, working with IPv6 for many years, as well as security. For this particular set of webinars, the cloud ones, Dr. Priyanka Sinha and Vivek Jain have helped run a lot of the testing, which has been really wonderful, and I really want to thank them for having helped out. So it's a team effort. So let's go ahead and get started. So what we're going to talk about is the level set first on what the address structure is for IPv6, just briefly, where extension headers fit in, kind of what we have done in terms of past extension header testing, and then we'll go on to the cloud topologies and the results. So here is the IPv6 main header, and you can see it's a relatively simple header. It has the version number, traffic class, flow label, and addresses, and it doesn't have too much more information in there. What has happened is that much of this information now is put into extension headers. So what happens is that in the next header field, which is in the next header field, will change to the first extension header, and then that will change to the next, and so on. Now, there is the extension headers must be in a certain order, and you can't duplicate them except for destination options, which can appear more than once. So these are some of the common extension headers: hop by hop, routing, fragment, and so on. You may be familiar with the ESP and authentication headers. Those have been back-ported to IPv4 and are used in IPsec. Much of that you will see when you're doing VPNs. So that is those are the extension headers, and there is a great deal of very good information in the extension headers. But the thing that we have been focusing on is that there are a number of people who say that extension headers do not work over the internet. And there have been a number of studies done, and by and large, they were broad-scale measurements going to very popular sites, the Alexa Top 1,000, 1 million, and so on. And by and large, they sent fake extension headers. They crafted extension headers, so it was not real traffic. And our point of view is that if extension headers do not work, or we can't figure out why they don't work, then a major good point, I will say, of IPv6, which is extensibility, is at risk. We don't want to have to do IPv10, IPv12, and so on, because we could not put in a function into the protocol. In the future, there will be many things that we will not know. We do not know what we need in 10 years, and just as we didn't know it 10 years ago where we might be. And there may be functions, no one can foresee that far into the future. And so you want a protocol that is extensible. And that is what has been driving us to do these studies. What we want to do is we're not doing broad scale measurements. We are doing deep dives. That is, we are not doing broad scale measurements of where things don't work. What we're trying to do is do a deep dive into various topologies and figure out where things work, and if they don't work, why. And so that will be the focus of these series. So what we did initially, and this was probably about a year and a half ago, we started and we used a small hosting service, not one of the name brand ones. That is, we didn't use Azure or Google or some of the large providers. We used a very small hosting service, and there's a reason behind that. These small hosting services are really connecting directly to the internet. They don't have a lot of intermediaries. It's the old internet, the way we used to think, is that you have a server, it connects directly, you have a client, it connects directly to the internet. As we know, that is not what happens really today. And we'll look at some of these topologies as we go on. And so what we did initially is we set up a number of locations throughout the world. As you can see, Warsaw, Toronto, Mumbai, etc. The reason for that is that in doing so, without having a huge number of sites, we could see that we were going across multiple ISPs, multiple transit networks, all over the world. And we modified the kernel for FreeBSD to send our destination options extension headers with every packet. We have now changed that so that we're using Ubuntu with eBPF. So there's just a slight thing about that is eBPF doesn't require changes to the kernel. It interacts with the kernel, but it's more of a you don't have to recompile the kernel, and so that's a better modification. But anyway, in any case, what we showed is that all of these worked. And so once we proved that, we proved standalone worked, we wanted to go on to other things. And as I say, we have a number of people who have been working with us. We have solved two major problems on the internet already. Two large providers have changed their offerings across the internet because of what we have found, and one of the cloud providers stands ready to work with us to do that. So what we did first after we tested the standalone is we started testing with CDNs, because as you know, especially if you go to the heavily trafficked sites, you're not going directly to Google or Facebook or whatever. you're actually going to a CDN edge or cache server that is closest to you, and your origin server is maybe far different and in a very different location than where you're going. And so as I say, we worked initially with CDN providers, and what we did is we moved our server to behind the CDN and took packet traces on both sides. And if you want, you can go back and look at what we found. As I said, there were some problems which two of the CDNs have fixed, and traffic is now going doing much better in terms of extension headers. So let's talk about cloud topologies, though. That is the focus of this particular presentation. And in fact, we'll probably do multiple presentations along this area. So when you talk about cloud topologies, there's a number of different ways that you can interact with the cloud. So let's start with a simple one. Let's say that you have something that's outside the cloud. Say my client is outside the cloud, and I'm going to somewhere inside. Well, outside the cloud can be, what does that mean exactly? You could have a standalone server like, for example, from one of our hosting services that's connecting directly to the internet going into the cloud, or vice versa. You could have the client inside. The client can be inside the cloud going to a standalone, or you can have something like a hybrid topology going somewhere from your data center into the cloud, but you're still somehow outside. You can also be inside the cloud completely. And if you're inside the cloud completely, you could be going from one data center inside the cloud or multiple data centers, and that will make a difference too. Or you could be going between clouds, going from one large provider to another, say Azure to Google, or whatever, Oracle, the number of whatever your provider is. So there's a number of different things to test. And what we have done in this particular set of tests is this. Let me do this. We have done this one, standalone to cloud, cloud to standalone, and then one data center. That's why I say is that we will be, this will take quite a while to do. We will take multiple ways. It will take multiple webinars to come to what we need. So let's talk about the simplest configuration. So what we have is our client. He's outside the cloud, and he's connecting directly to the internet. We used one of our small hosting services, which connects directly. We used that. And then we put one of our servers inside the cloud. So let's see how that is. So now what we have is the other way too is we have the standalone server is outside the cloud, and we have the client who is inside the cloud. So let's start looking at some of the testing results. So first thing we want to do is say, are we actually being able to send traffic? So what we did, as I say, in this case, the cloud is the client, the :1::: address that is inside the cloud, and he is going to our server, which is outside the :1527. And you can see the SYN packet being sent, SYN ACK, so TCP connection. is done. We did a get HTTP, and everything was working correctly. So you can see that we do have traffic. So that's the first thing. We want to make sure that without extension headers that we can get there, because we could, of course, have a configuration problem of some kind, or firewalls or whatever. But you can see that we have connectivity. We're going back and forth, sending traffic. Also, this is real traffic. We have an HTTP server running in one place. So we're not sending fake data of any kind. And I feel that is important. And if you look up that :1::: address, you can see, if you go to Aaron, the who is on Aaron, and you can see it is we've hidden the cloud provider. It is that particular cloud provider's one of their IP address, and so on. So yes, that is a cloud based address. So what do we know so far is that our addressing and firewalls are set up, HTTP server is set up, traffic is going back and forth. So the bottom line of this is IPv6 with no extension headers works fine. But we did both ping and HTTP, and we also did a client inside or outside cloud. All worked just perfectly fine. So let's keep going then. So then what we did is we added extension headers. And this time we added extension headers actually on both sides, but you can see this one. This is the ::1 address, the one that's inside the cloud. And you can see here the destination options for IPv6. That is the next header. That is an extension header. And we went ahead and put that up here too. We can see destination options, that it does have it. What do we see here? So what we see here is that the client started to send the SYN. He sent it, and he retransmitted the SYN multiple times, because somehow we didn't get the SYN ACK from the other side. And then he does it again, and he will keep doing it. So let's see where we are. And so when we traced on the other side, which is the server side, what do we see? We see only IPv4 packets. We don't see any IPv6 coming to the other side. And so let's try going the other way. So then we went from our 1527, that is our standalone client, and you can see he has destination options also, going into the cloud server. And you can see the SYNs going. The packet is produced with the SYN, but somehow it never makes it to the other end. So when we do the trace on the other side, there is only IPv4. So what the bottom line is for this is now cloud provider 1 with extension headers doesn't work. So the client can be inside the cloud or outside the cloud, doesn't seem to make any difference. But what's interesting is that the OS supports EHs. You can see we modified that. Those are both Ubuntu machines. We modified the cloud-based Ubuntu, and he was certainly sending out extension headers. He was trying to send SYN packets. They weren't getting through. Whatever is going on in the quote-unquote network is not supporting extension headers. So what is that network? So really what we have here is inside the cloud topologies, you're not going directly. There's a number of boxes inside there, third-party boxes, who knows what, inside their network that maybe by policy or maybe via a bug or whatever are not supporting it. We checked all the firewalls, and the firewalls are not EH aware. That is, there's no way to stop extension headers or filter for extension headers within the firewalls that we could find. And so this is a problem that we will escalate to the cloud vendor to see if they care to do anything about it. As I say, one cloud vendor has already said that they stand ready to work with us. What I will tell you is that when we worked with the CDN vendors, one of the CDN vendors found a bug in their load balancer code, and they fixed it and rolled it out. And after that, extension headers worked perfectly correctly. So the point here is that sometimes there is a problem, and even the provider themselves doesn't necessarily know that there is a problem, because this is I don't know. I suppose people have thought for a long time extension headers didn't work, and so they didn't bother to test it. I don't know. I can't explain why these were not tested. I mean, I don't work for these organizations. Anyway, so let us continue. Cloud testing. Let's go inside the cloud alone. So again, let's go for a simple scenario. We're going to go from a client, which is inside the cloud, to a server, which is also inside the cloud. And as you know, cloud providers often have multiple data centers. And so we did it to a single data center within the cloud. Let's just do that, see where we are. And so what we did here is, remember our :1::: address, we use that. Now we have a :2 address as well. And again, if we look up on Aaron, you can see, of course, :1 is a cloud address. You can see right there. If you look at the :2 address, that also is a cloud address. But you know, initially we were thinking, well, you know, even inside the cloud, we could have unknown third-party boxes that are in between. So it's possible that even inside the cloud, even if you think that you're going directly, maybe you are not actually going directly. So let's do this. So first we said, well, let's do a ping from one address to the other. And so you can see we're going from the :1 address to the :2 address. Both sides have the destination option. And you can see here, it is working fine. We did an echo ping request. It was responded to by a ping reply, and so forth. So huzzah, that all works just fine. So now let's see if we can do some HTTP traffic. Oh, well, good Lord, that also works really well. You can see here going from inside the cloud, :1 to :2 with destination options. You'd see the SYN, SYNAC, ACK, and the GET, HTTP OK. You see our destination options. So we are seeing both sides working just fine, using a ping and HTTP on global unicast addresses. One of the interesting things we found when we did traces is that it turned out that there was some link local traffic going on, and our link local traffic happened to have extension headers too. The way we do the Ubuntu modifications with eBPF is that it will just attach our destination option header to any particular, to any IPv6 packet. Doesn't matter if it's global unicast, if it's link local, whatever, TCP, UDP, it doesn't matter. So you can see here, this is our link local address. You can see the FE80::4001, etc. And you can see here is that the next header here is UDP. We have our destination options here. Turns out this is a UDP packet doing DHCP. And you can see here, it was a renew, and you can see the XID as well as the CID for DHCP are matching. And in this case, one side had destination option, one has an extension header, and the other side did not. But it all seemed to work just fine. So we were real happy with that. And if you look on the other side, you can see that it works just fine from that end also. So the bottom line for here is, if you're going inside the cloud alone, so with cloud provider number one, IPv6 extension headers seem to work just fine. The OS supports it, and whatever is inside the internal network doesn't seem to be a factor. So that's great. That's great. I tell you, it gives me hope that going outside, there may just be one small policy or one small box which needs to be changed, and then we can go outside the cloud as well. Maybe that's wishful thinking, but we will start that conversation with the one cloud provider who wishes to work with us. And link local as well as global unicast is working. And of course, the upper layer protocol, TCP, UDP, and so on, those are, of course, not a factor because we are at the IP layer. Of course, the cloud provider has multiple data centers, and we do not know if we had what would happen if we got a cloud address at a different data center. That is one of the things that we would like to test. So what we're doing now is we will test with more cloud providers, and then what we want to try to do is work with them so that they can fix the problem, and then we can retest, and then we will continue, of course, to work with other things such as routers, ISPs, and so on. And interestingly enough, load balancers are a very interesting area where things may be getting dropped. I would not have thought of those when I first started getting into this, but they seem to be somewhat implicated. And of course, we need to test all extension headers and not just the ones that we are doing today, which is which is the destination options. So there's a lot of interesting work to do. What I'm doing now is I'm going to make Priyanka and Mike Ackerman panelists. So if they want to add anything, they can. Both Mike and Priyanka have worked closely on this. And in fact, we need to thank Priyanka for doing the actual logistics of the testing and getting all the addresses and capturing all the traces. So thanks so much, Priyanka. So anything that you guys want to say, any questions from anybody, please put it in the chat window. Let me look and see if there are questions already. Let me go over there and see the questions. Or if you guys have anything you want to talk about, please let me know. So.
Nalini, this is Mike. Can I say something real quick?
Oh, please.
First
Yeah, go
off,
ahead.
thank you so much for doing this. This is extremely beneficial to those of us in enterprises and others that maybe understand this a little and need to understand it a whole lot more. And I think part of the whole lot more that we need to understand, I mean, you're showing us how it works and everything. And what I think we don't understand, and maybe this is a future webinar, is some of the ways that this can be used and how it provides value to large organizations and large network operators. And I think there's a bunch of things in a bunch of functions in extension headers that will allow us to do that, and may even be reasons for us to deploy IPv6 more readily or more sooner than later. And so I want to thank you for bringing this up. And then is there a chance that that's a future webinar, like sort of a use case based thing and how it provides benefit to large organizations?
Yeah, no, I'm really glad you said that. And there's another comment in the chat window from a participant, which actually goes along those lines too. And I'm going to invite that participant, who is Andre. He's on our EAC, to go ahead, and I've unmuted him. So if he wants to go ahead and chime into it, that would be great. But yes, and let me tell you his question first. And his question was, we need to distinguish between the enlargement of the address space and extension of functionality, which is really true. So let me address that one first, and then I'll address yours. So IPv6, of course, allows you to have a larger number of addresses. Of course, that was the initial impetus, is that we were running out of IPv4 addresses. But extension of functionality is something different. And that's the kind of thing Mike is talking about. Because, it may be like, well, why the heck, what functions are we talking about? Why would you need to add functions? What is this that we're doing? And so actually, there's a number of us, and including I think Mike, and that's why he knows it, is that we are working on a use cases draft, which will be submitted to V6 Ops any day now. It's because the deadline is July 10th to go to this IETF. I encourage everybody to attend the V6 Ops session at IETF. Remote attendance is completely free, and we hope to be talking about our use cases draft. And what I'll do, once it's posted and once the cloud testing draft is posted, I'll go ahead and send an email out when we send out the webinar slides and everything, with the links to those. Because I think what Mike is saying is extremely correct, is that there are quite a few extension headers that are in use already, a lot of functionality, a lot of people are seeing reasons why this should be done and what can be done. I mean, I'll just talk about one real briefly, which is one that we're very familiar with, which is our performance and destination and diagnostics metrics. What we did with that is we embedded performance and diagnostic metrics in each packet, so that you can separate server time versus network time, as well as see the packet flow. See if you have multiple retransmissions, and it's all embedded inside the packet, so you don't need something external to be at work. And I'll tell you, right as we speak, I'm doing a consulting contract with an organization out here. Unfortunately, they have V4 only, but that is exactly their problem. They have a large network, and they don't know if the problem is in their application or in the server. What they're saying is, in the morning, they have like 2-second response time, but in the afternoon, for some reason, they have 15-second or even 1-minute response time. And I said, this is exactly the problem that we wanted to figure out with our the IPv6 extension header, the performance diagnostics metric, is to distinguish where the problem is. And so you can see that may be quite helpful to you. And there's so much more. And I think we definitely should do a use case, extension header use cases webinar. Did I answer your question, Mike?
And then some. And let me just emphasize what you said, that that PDM would be super helpful to us. All of us network operators, we buy all these applications and spend big bucks and build these infrastructures to record that information. And sadly, sometimes it's not even accurate, or sometimes the different tools disagree. PDM is not only free to us, which is a huge word for us in enterprises, but it's also accurate because it's part of the protocol. It's not something external taking measurements and then giving you some kind of processed results. This is actually what's happening in the protocol itself. So there's two real huge major advantages. And then the last thing I'm going to say, I promise, is just to reemphasize what I said up front. I know how much time you and Priyanka and a few other people put into this. You're not getting anything out of it other than seeing us and enterprises learn more about this and become more dangerous in terms of deploying IPv6 and running our networks better. So thank you. And that's all from me.
No, thank you, Mike. Andre, did you want to talk anything about this, or did I answer your question as well?
Hi, Nalini, can you hear me?
Yes, we can hear you fine,
great.
Andre.
You answered my question about the distinction between the address space expansion and the extension of functionality. Those are two distinct value adds. They're orthogonal to one another and they reinforce each other. So from everything I'm hearing, that should reinforce the case for adoption. The difficulty that I'm hearing in your talk is that there isn't universal network acceptance. And I'm wondering, since the internet is a connectionless architecture, whether there's any way to constrain the path that's followed by packets, tunneling or something like that, so that you only traverse network nodes that are going to be compliant with V6 and not drop packets on the way.
That's a very interesting question, Andre. So one of the things that I'll tell you is when we initially started getting into this, we were wondering, okay, so where are packets being dropped? Are they being dropped at the, some packets can be dropped at the OS itself. Like, for example, like if you have a Linux OS, or if you're doing a pad-in, which is a certain kind of extension header that is not formatted correctly, the OS itself will drop it, as it should. But certain routers will drop certain extension headers themselves. So we didn't know if it would be inside the OS itself, whether it would be in a transit network somewhere along the way, or where it would be. And so far, what we seem to have found, and again, we have not done broad scale measurements, and I'll tell you one result in broad scale measurements, which is interesting. So in our measurements, what we seem to be finding is that it's not the path necessarily, it's the destination or source network, which is actually an easier problem to solve. Let me stop there and see if I'm making sense to you, Andre.
Indeed you are. You've simplified the problem as far as we know. It seems to me that when you're making up a migration plan, you need to very precisely identify the components that are going to be traversed on the way, whether it's a network element, a network provider, or an OS, so that the problem can be rectified before we go into test, let alone going live.
Excellent, Andre. So what we want to do is we want to work with these providers ahead of time before you guys, the enterprises fall into this trap. ideally, what we want to do is have this particular cloud provider or others. So what I'll show you is just interim results show that there's a second large cloud provider, which also seems to show some of this behavior. We have not done, enough testing on that one. And a third cloud provider seems to pass everything just fine. And I don't want to do marketing for any cloud provider. And so everybody is like, we will not name any names on here. People should, yeah. So you can do your own testing too and see if it works. So what we want to do is we would like to solve these problems before you guys fall into it, which is the enterprise networks, because I think in some ways, I totally hear what you're saying, Andre, but in some ways that way madness lies. There are ways to route your network in certain ways, or route the path in certain ways. And in fact, there is an extension header, the source routing header, that all that work is around specifically defining the path for these headers, or segment routing. Sorry about that. It's segment routing, which will route the packet explicitly. But I think the problem is these are quote unquote transparent boxes inside the topology that don't have an IPv6 address even, so you can't route around it. So it's even a different problem. As I say, some internal conversations with one of the cloud providers, who fortunately is showing some of this behavior, is they said, okay, let's get the traces. God knows how many third-party boxes we have in between. And then, of course, they're going to spend a bunch of time pointing from one finger to the other. They're saying it's, not my fault, it's his fault, and so on. And we'll work through that. Am I making sense to you, Andre, about
Yes,
what
you
you said?
are making sense. I also understand the sensitivities of which we all need to be aware. Maybe I don't have enough depth with this. It seems to be analogous to the problem of not allowing packets to go through a designated country or something like that, to me. Am I missing something?
Yeah, I don't know. I hear what you're saying. That's a very good question.
Dependency. On the one hand, you're using source routing to solve the problem. On the other hand, the source routing is in the extension header, which is the cause of the problem in the first place.
Well, yes. The segment routing, which is essentially source routing, that will work if there's an address to route around or to and from.
Got it.
Yeah, but if there's so it's an interesting problem, and because the blocking countries and so on, that can be done at multiple layers, and maybe Mike or Priyanka want to chime in on that one. That can even be done through, of course DNS, but BGP also. I think, as I say, the last problem we found, where the person was, where the provider was candid and open with us and worked with us to fix it, the last problem we found was in a bug in a load balancer. And I am hoping that this problem with at least one of the cloud providers will not be a policy, but a bug. Policy is a different question. You know what I mean? If somebody makes it a policy to block extension headers, that is a very different statement. And if they're going to make that statement, they need to make it publicly so that we know, that these functions are not going to be supported in our environment. Or if they're open to it and we do testing, and then if they're, as I said, I don't want to name names without getting their approval, And so, but if they make it public, we are considering something like an operational draft a best current practice for extension headers. As I said, that's still up in the air. We're going back and forth about if we should do it. The current best practices is that extension headers should be supported. What people are doing is a different question. And you can see just in what I showed, it's a mishmash, if you will. That's the technical term, which in some ways, when you don't have consistent implementation within your own network, that's problematic. I can think of a number of things which could go quite wrong because of this flaw. Do I make sense to you?
Yeah, sure. I'm thinking of lots of analogies, which I should probably discuss with you offline because I can see that we're running low on time. But
yes.
Some really interesting problems here, some of which relate to other things like auto discovery and so on as well.
Yes, thank you so much for your comments, Andre and Mike. Any other questions from anybody? We will continue on doing our research. We will be presenting this at the IEPG, a subset of this at the IEPG at the IETF, and we hope to be presenting at V6 Ops as well. So anyway, so Priyanka, do you want to say anything? Thank you so much for your work on this. If there's any, hearing no other comments, thank you all so much for your
Nalini, can I say one more? Can I say one more thing, just in response to Andre's questions? Andre always asked some very intriguing questions, very thought-provoking, and he's done it again. A lot of what he said, and you alluded to this, is beyond the topic of extension headers, which is today's topic. Doesn't mean they're not important, and maybe it makes them even more important. So to the extent that any of Andre's questions have piqued interest in anybody's mind, let Nalini or any of us know, is this a topic for a future webinar? So like a lot of things issues that Andre mentioned are not going to be resolved or caused by extension headers, but they might be firewall issues or routing issues, BGP, maybe even proxies. And maybe we should explore those areas in more detail in the future as well. So that's my only comment, and thanks for the great questions, Andre. Keep them coming.
Yeah, thank you guys so much. So yeah, anyway, if anybody thinks of a question later, please let me know. As I said, this session will be recorded, or is recorded, and we will send the recording as well as the slides out afterwards. Thank you all so much for your interest. Bye.